Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on March 4th, 2026, just yesterday. It introduces Helios, a 14 billion parameter video generation model that achieves inference speeds of 19.5 frames per second on a single NVIDIA H100 GPU. The paper is titled Helios, Real-to-Real Time Long Video Generation Model. And as we'll see later, the approach manages to match the quality of strong baselines while drastically cutting down on computational costs. And for those interested in the implementation, the authors have shared their code on GitHub. On Hugging Face, the 14 billion parameter weights for Helios base, mid, and distilled are ready. You will also find examples for text and image to video generation. Now, Figure 2 details the benchmark performance for both long and short durations. On the left, looking at long video generation, Helios base and Helios distilled take the clear lead with scores around 6.6 and 6.3. This dominance suggests they effectively mitigate the quality degradation often seen in extended clips from models like Long-Live. Then on the right, for short video generation, Helios base remains highly competitive, virtually tying with the strong WAN 2.2 model. So whether the task involves sustaining a minute-long sequence or generating a standard short clip, Helios matches or exceeds the quality of its peers. While Figure 2 focused on quality, Figure 1 reveals the massive efficiency gains in frames per second on a single H100 GPU. The standout here is the dark blue bar for Helios distilled, which clocks in at over 19.5 frames per second. Remarkably, this speed rivals the striped gray bars on the left, which correspond to much smaller 1.3 billion parameter models. In contrast, the solid gray bars on the right show that other large models, like Crea 14b, are significantly slower. This demonstrates that Helios delivers the complex modeling of a large network without the typical heavy computational cost. Now, Figure 4 breaks down the architecture that makes this possible. The core system is an autoregressive video diffusion transformer. On the bottom left, the diagram highlights multi-term memory patchification, which compresses historical frames into varying levels of detail to save compute. Adjacent to it, the representation control module adapts the input for text, image, or video tasks by simply adjusting context padding. Moving up, the Pyramid Unified Predictor Corrector progressively refines the video from low to high resolution. Finally, the panel on the right details the internal block structure, showing how attention mechanisms integrate these historical signals. So, having seen the architecture, Table 1 lists the concrete training recipes for the first two stages. Starting at the top, the global batch size ramps up from 128 in Stage 1 to 256 in Stage 2. Below that, the team uses the AtomW optimizer and bfloat 16 precision, distributed over a cluster of 64 NVIDIA H100 GPUs. Most importantly, the bottom row specifies the history corrupt ratio parameters. These settings control how much noise is injected into historical frames during training, ensuring the model learns to recover from drifting errors. Well, moving to the quantitative results, Table 3 compares performance on short 81-frame videos. The upper sections list extensive baselines, from SANA to WAN 2.1. But looking at the bottom rows, Helios distilled really breaks away from the pack. It achieves a throughput of 19.5 frames per second, which is exceptionally fast for a 14 billion parameter model. Crucially, its total quality score of 6.0 holds steady, proving that this speed doesn't compromise visual fidelity. While Table 3 focused on short clips, Table 4 expands the evaluation to long video generation, covering sequences up to 1,440 frames. The bottom section highlights the Helios models, where Helios distilled specifically achieves a top quality score of 6.94. This beats strong baselines like rolling forcing and Long-Live, shown in the middle block. It does this at 19.53 frames per second, while competitors like Long Cat Video crawl at 0.33. The columns on the far right also show that Helios minimizes drifting, effectively preserving consistency over time. Wrapping up, two takeaways stand out. Helios demonstrates that massive 14 billion parameter models can run in real time on a single GPU, and it solves the long-term drifting problem through smart training rather than complex inference hacks. This opens the door for truly interactive video applications. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.